Why Pluto, this tiny, icy world, is so slow in its orbit? Let's delve into the mystery of Pluto, a celestial body that has always intrigued astronomers and space enthusiasts alike. Discovered in the year 1930 by the American astronomer Clyde Tombaugh, Pluto was initially celebrated as the ninth planet of our solar system. Dwarfed by its neighboring giants, this little icy sphere, situated at the fringes of our solar system, has always been the subject of much curiosity and debate. Pluto's status as a planet was uncontested for more than half a century. But here's where things get interesting. Pluto's orbit around the Sun is unlike any other planet in our solar system. While Earth takes a mere 365 days to complete one orbit around the Sun, Pluto, on the other hand, takes a whopping 248 Earth years to do the same. This is primarily due to Pluto's highly elliptical and inclined orbit. Unlike the near-circular orbits of the inner planets, Pluto's path around the Sun is more elongated and tilted. This unique trajectory at times brings Pluto closer to the Sun than Neptune, only to swing it out to more remote regions for the majority of its orbital period. But why is Pluto's orbit so different? And why does it take so long to complete one cycle around the Sun? The answer lies in a combination of factors, including Pluto's distance from the Sun, its small size, and its unique orbital characteristics. So as we venture further into the exploration of our solar system and beyond, we continue to unravel fascinating facts and mysteries about these distant celestial bodies. It's a reminder of how much we've learned and yet how much there still is to discover. So the question is, why does Pluto take so long to orbit the Sun? And as we journey through the cosmos in search of answers, we might just find that the mystery of Pluto is just a piece of an even bigger cosmic puzzle. The answer to Pluto's slow orbit lies in its unique path around the Sun. Now, when we think of a planet's orbit, we often imagine a perfect circle. But in reality, orbits are more like stretched-out circles or ellipses. Pluto's orbit, however, takes this to the extreme. It's more elongated and tilted than those of any other planets in our solar system. Let's break this down. Most of the planets orbit the Sun on a similar plane, like cars on a racetrack. But Pluto, the rebel of the solar system, doesn't follow this norm. Its orbit is tilted by a whopping 17 degrees to the plane of the ecliptic, which is the imaginary flat surface that we could draw all the other planets' orbits on. This means that sometimes Pluto is above the plane of the solar system, and sometimes it's below. And it doesn't stop there. Pluto's orbit is also highly elliptical, more so than any other planet. This means that its distance from the Sun varies quite dramatically. At its closest, Pluto is about 30 times as far from the Sun as Earth is. But at its furthest, it's nearly 50 times that distance. This significant variation in distance affects the speed at which Pluto orbits the Sun. You see, the speed of a planet's orbit isn't constant. It's faster when the planet is closer to the Sun, and slower when it's further away. This is due to the laws of gravity and motion, first described by Sir Isaac Newton. So, because Pluto spends a good chunk of its orbit very far from the Sun, it travels at a slower average speed. In fact, Pluto's orbit is so elongated and tilted that it sometimes comes closer to the Sun than Neptune, making it the eighth planet for a brief period of time. This last happened between 1979 and 1999 and won't happen again until the 23rd century. But there's more to Pluto's slow speed than just its orbit. So buckle up as we dive deeper into the intriguing world of this distant, icy dwarf planet. Pluto's mass and the gravitational pull it experiences also play a significant role in its slow journey around the Sun. Let's dive deeper into the physics of this. Gravity, as we know, is the force that attracts two bodies towards each other. The Sun, being the heavyweight champion in our solar system, exerts a significant gravitational pull on all the planets, including Pluto. This force of attraction causes the planets to orbit around the Sun. However, the speed at which a planet orbits the Sun isn't the same for all. This speed, or orbital velocity, is influenced by the gravitational pull between the planet and the Sun. The closer a planet is to the Sun, the stronger this gravitational pull is, causing the planet to move faster to balance this pull. Now, let's think about Pluto. It's situated at the outer reaches of our solar system, approximately 3.67 billion miles away from the Sun. That's quite a distance. Because of this vast separation, the Sun's gravitational pull on Pluto is notably weaker compared to the inner planets. But remember, gravity isn't the only player here. Pluto's mass also factors into the equation. With a mass just 1/500th that of Earth, Pluto is a lightweight in the planetary lineup. This small mass means that even the Sun's diminished gravitational pull at that distance is enough to keep Pluto in orbit. However, the weaker pull also means that Pluto doesn't need to travel as fast as the larger, closer planets to maintain its orbit. So, it's a combination of these factors, Pluto's far-off location from the Sun and its small mass, that causes Pluto to move at a slower pace. It takes Pluto a whopping 248 Earth years to complete one orbit around the Sun. So, Pluto's small size and far-off orbit combine to make it the slowest planet in our solar system. Now let's delve into the controversy surrounding Pluto's planetary status. In the year 2006, the International Astronomical Union, or IAU, shook the astronomical world to its core. They made a decision that would forever change how we perceive our solar system. They demoted Pluto from its planetary status to that of a dwarf planet. The primary reason? Pluto's inability to clear its orbit of other debris. To understand this, it's important to know that one of the criteria for an object to be classified as a planet is that it must clear its orbit. In other words, it must be the dominant gravitational force within its orbit and hence remove other bodies either by consuming them or by flinging them into different orbits. However, Pluto, with its smaller mass and unique elliptical orbit, shares its path with other icy objects in the Kuiper Belt. This decision by the IAU was met with a mixed response. Some agreed, stating that the reclassification was a necessary step in the evolution of our understanding of the cosmos. They argued that Pluto had more in common with the numerous icy bodies in the Kuiper Belt than with the 8 planets in our solar system. However, others were less convinced. Critics of the decision argued that the criterion for a planet to clear its orbit is not as clear-cut as it seems. They pointed out that even Earth shares its orbit with thousands of near-Earth objects. Moreover, they argued that the unique characteristics of Pluto, such as its complex seasons and the presence of an atmosphere, make it more similar to the other planets than the IAU's decision would suggest. This debate still rages on today, with scientists and space enthusiasts alike passionately defending their views. It's a testament to the dynamic and ever-evolving nature of our understanding of the universe. Whether or not you believe Pluto should be classified as a planet, there's no denying its unique characteristics and intrigue. So we've uncovered the reasons behind Pluto's slow orbit and explored the controversy around its status. Let's take a moment to summarize the key points we've discussed. Pluto's orbit is unique, tracing an elongated path that takes it inside and then outside Neptune's orbit. This peculiarity is due to its small mass and the gravitational influences of its neighbors. Gravity plays a significant role in Pluto's slow orbital speed. Its small mass means it has less gravity to pull it along its orbit, resulting in a slow pace that takes it 248 Earth years to complete one journey around the Sun. And then there's the debate about its classification. Once considered the 9th planet, Pluto was reclassified as a dwarf planet in 2006.